All right, so we're on chapter 3, determining change and derivatives, and this is section 3.5 on rates of change for functions that can be multiplied. So we can construct new functions by multiplying them together. Now, each of the two functions, though, used in that multiplication is going to affect the rate of change of the overall product. Okay, so what we're going to have is we're going to have a rate of change notation for function multiplication. So we're going to have basically a new derivative we can look at. So if we have a product, basically our first function times our second function, then the derivative of that product is going to be, we're going to take a derivative of the first function times the second function plus the first function times the derivative of the second function. So, and kind of mathematics looking thing with the derivative signs and everything. So if we have f and g are differentiable functions of x, then the derivative of the product, basically our product is just f of x times g of x, then that derivative is going to be f prime of x times g of x plus g prime of x times f of x. Okay, so derivative of the first times the second, and then now this is where we have some differences that you can find. Sometimes it'll say f prime times g and then f times g prime. Sometimes it'll be g prime times fx. So either way, because multiplication, you change any order and it's still going to multiply the same. It doesn't matter which way you do it, but you want to try to get into a habit of doing it one way or the other. So whether you do it as fx times g prime x, or you do it g prime x times fx. Either way, doesn't matter. Over here, notice we did the derivative of the first, and then the first function, the second, and the derivative of the second. So we kind of kept the first, second order. Here, they didn't do that, but it doesn't really matter as long as you make sure to remember how it goes. So say, for instance, we had f of x is equal to 4 times 3 to the x, and g of x is 5 times x squared. How are we going to get that? Well, the product is just going to be this times this. Well, this times this gives us that. Now, could we simplify that? Yeah, we could take 4 times 5 and get 20 x squared times 3 to the x. But we don't have to. We can just leave it as that. Now, what is the rate of change of the product function? Well, what we're going to have to do is we need to find f prime of x, which is going to be, well, it's going to be 4, and then it's going to be times. Now, when we have something like a b to the x, it's going to be ln of b, which is 3, times 3 to the x in this case. And our g prime of x, well, we're just going to take that, and that's going to be 10x. Okay, so now we've got f of x, f prime of x, g of x, g prime of x, and now we can plug into this formula up here. So f times g prime of x is going to be our derivative of f with respect to x times g of x plus f of x times g prime of x, basically. So we plug in our values. So we're going to have here 4 ln of 3 times 3x, because that's the derivative. So that's our, f prime of x, times 5x squared. Well, the 5x squared is just our g of x. And then here we have our f of x, and then this was our g prime of x. And so now we just have that. Now, can we simplify this one? Yeah, we could simplify. We could take, 10 times 4 times 5 times ln of 3 times 4 and get that whole thing. And if we do multiply it all together, we get 21.972, and that's times the x squared times the 3 to the x. Okay, well, actually we have to do each part. Sorry, I was multiplying, I forgot there's an addition here. So we're going to take 4 times ln of 3 times the 5 and get the 21.972, and then that has an x squared, and then we have 3 to the x, and then we have the plus, and then now we can take 4 times 10 times x and get 40x, and then still 3 to the x. Okay, and then that would be our final thing. I forgot we had that plus in there. All right, so that's kind of how it's going to be. And so, they're going to give us some f and g or a and b or whatever the functions are. We will write a product, and then we'll write out the derivative. So I'll pause there and I'll come back for examples.